So this video is about principal component analysis. This is like the heart of predictive models nowadays. It's very large subject with a lot of applications. Theoretically, it goes. There's many PhD dissertations on this, and more to be written even. There's a lot of applications that this uses. The one I've been taught was in my bioinformatics class, and we use singular value decomposition, and the linear algebra behind how this works is shown right here. In the class, we just, not too much was required because there are functions in computer languages that you write, and then you put the genome, and you can generate this stuff very easily. But if you were doing it by hand, and the people who write their dissertation who create new topics and applications from this, new variants, you gotta know it. It's hard stuff. Briefly, I want to jump to the applications, because I believe that the applications are endless. This is the heart of applied data science. And it can be used in quantitative finance, neuroscience. But the way I would want to show right now is, here we go. This uses this article by Alan Nelson, which I was looking, just when I'm bored, I go on GitHub, generate creative ideas, see what people are working on, copy all their stuff. But yeah, here I feel like it's new research, and it's actually stuff I saw on the news about how China is messing with satellites to hide certain important locations, so we don't have, our spy planes and spy drones don't have accurate data with regards to where certain missile sites are, right? And so one way to approach this, many ways to fix this, but theoretically this is the heart of the algorithms that can do this. Change detection with Google Earth Engine imagery, right? With the MAD algorithm, using optical and infrared imagery as their data sets. And the last thing is perform principal component analysis in visual infrared full scenes. So, that's the point of this video. It's going to take me a while to understand all of it, but it's understandable, and if I have to. Just keep following the links, Keep following the links, like, Dora from Finding Nemo. Keep following the links.